Hello guys, hope you're doing okay. Good morning, good afternoon, good evening, wherever you are, whatever time it is. I hope you're having a good Songkran break. Now today I'm going to introduce video 2. Video 1 most likely you've watched already. That was with Mr. Majid on graphing sine and cos. Today, or in this video, you'll be learning how to basically it's basically the introduction to unit circle. Now you've had some introduction by me in video 2 where we kind of looked at the unit circle very briefly, but today you'll realize why this is important, a bit more rules and background as far as what the unit circle is used for, but again, that's kind of lay down some probably things that you know already, right? You probably know that basically these values have a radius of 1, right? No matter where I go, whether it's right, left, up, down, no matter where I go, at least it's from the origin to the radius, I know that value has a value of 1. Okay, it's pretty important to know about a unit circle. It has a value of 1. So no matter where I go from the origin to the end of the circle, it always has a value of 1, a radius of 1. Now, let's look at one specific point, right? Let's call this x and y. Okay. What I'm about to do in just a few moments is we're about to prove that xy, right, is actually equivalent to cos comma sine, right? So this and this mean the exact same thing. Okay. Now let's kind of lay down some groundwork. We already know that our radius is going to be 1. We already know that hypotenuse has a value of 1. Okay. Now, let's go ahead and lay down our x and our y. Okay. So again, this would have a value of x. How many times to the right or left? In this case, how many times to the right does it go? And our y, right? How many times upwards? In this case, upwards does it go to end up getting our value of y? Okay. And again, we want to basically prove that cos is equal to x and sine is equal to y. So sine is equal to y and cos is equal to x. Now how do we do that? Okay, it's actually pretty simple. Now considering this right triangle, let's go ahead and develop cos first, right? So what is cos theta? Is it actually x, right? Well, cos theta, again, remember what cos means. Cos means adjacent over hypotenuse. Let's go ahead and label these sides. Again, this is opposite. This is, of course, hypotenuse. And this is adjacent. Now, cos being adjacent over hypotenuse, that would end up being x over 1. Well, again, quite simply, we've proven that this cos theta is equal to our x. It's equal to this value here. Okay? Now, when it comes to sine theta, right? Very similar way. Sine theta is equal to what? Opposite over hypotenuse. That means y over 1. Well, I know that sine theta would have to equal y, right? Again, this value right here. Okay? That's something important to remember. So, for instance, if I ask you cos 90 and sine 90, well, that's actually, you don't have to use your calculator. You don't have to even start developing a right triangle, because that value, again, what we'll start developing on the next slide is what are these actually functions? What are these values actually equivalent to, right? Cos 90. Well, again, if I know that cos is equal to x and sine is equal to y, I know this is also equal to cos and sine, right? So if I'm asking cos 90, which again, this is a 90-degree angle, it has a value of 90, so cos 90 would actually be equal to 0. And then sine 90, well, that has a value of 1. So this is why, again, we'll start developing this a bit further on the next slide, but I wanted to prove basically sine theta is equal to y and cos is equal to x. So as you can see, we have our unit circle. What I want you to do, just for your sake and for you to know this as best as possible, I want you to draw this unit circle one more time, and I also want you to write it, draw it pretty big. The reason is because we're going to fill this unit circle out one piece at a time, and I want you to have a big representation so you're not like trying to fit everything in one small space. So write this unit circle pretty big on at least a half piece of paper, and we'll do this piece by piece, okay? Now let's start with 0, right? This theta goes nowhere anti-clockwise, and we have a value of 0, and a value or angle of 0 has the value of cos being equal to 1 and sine being equal to 0. Now we're going to work our way to Q1, and then basically if you know Q1, you basically know the rest of this unit circle, and I'll explain in a few moments. Okay, so these three angles are represented as the angle or base angle of 30, 45, and 60. Okay. Now these angles are also represented by these values: cos, which is equal to square root 3/2, sine, which is equal to 1/2, 45, which is equal to that, and 60, the angle of 60, which is equal to that, 90 being represented, as we know, as 0, 1. Okay. Now you're probably wondering why the heck, or how the heck did you come up with that number, right, on your unit circle? Because these values are a bit messy, but let me explain, right? Because you basically have done this already, right? Remind yourself that this is cos and this is sine, right? Your x and y values is equal to cos and sine. Okay, so if you're wondering, how did I get cos of square root of 3/2? Well, again, it's those unit circles or these special right triangles that we already know. Okay, now we already know this, so I'm going to put that to the side, and I'm going to do one of these just to prove to you why we actually get those values, right? So, for instance, if we're looking at the value of 30, well, that has an angle or a base angle of 30, like we said. It has a angle of 90, and it also has a value of 60. Okay, so let's go ahead and fill out our ratios, right? We have this as 1, across from 90 is 2, and across from 60 is 3, or square root of 3. Okay, and again, these values we already know already, or should be very familiar with. So if I ask you, well, cos 30, right, which I've asked you a couple of times throughout this lesson, or throughout this chapter. If I asked you cos 30, well, cos 30 would end up being, let's see, cos 30 is adjacent over hypotenuse, so that will end up being square root of 3/2, just like how we end up getting here. If I asked you sine 30, well, again, what is that value? That value should be 1/2. Opposite is 1. Hypotenuse should end up being 2. And just like how we get here, sine is equal to 1/2, we can represent that. We can at least show the work when it comes to that. Now, the good part is, if you memorize Q1, you can basically give me anything across this unit circle. Okay? Now, you might think this is a lot to memorize. It's actually pretty easy. I'll show you why. Notice, when it comes to all these values, everything has a denominator of 2, right? So everything is over 2. So, again, that's pretty easy to know. How do we get the top values? Notice the pattern here. We go from 1, 2, 3, and then we go 1, 2, 3. Well, there's a pattern there that you can also memorize. Okay. Now, everything on the numerator has a square root. Obviously, square root of 1 is equivalent to 1, so we don't represent the square root there. But everything else on the numerator has a square root. Okay, so that's also something you have to memorize. Now, the reason you memorize Q1 is because when it comes to Q2, Q3, and Q4, you basically have the same ratios, right? Because they're the same right triangle that you're doing over and over again. So, for instance, let's do the angles of Q2, right? I'm going to have the angles of 120, 135, and 150. Now again, remind yourself, this still has the base angle of 60, base angle of 45, and the base angle of 150. They're still going to be represented with the same ratios, except what's the difference, right? The difference here is cos is negative and sine is positive, which makes sense, right? We know that the only thing positive here should be sine. And as you can see, sine is positive here, sine is positive here, and sine is positive here. Well, let's look at cosine. Cosine is negative, cosine is negative, cosine is negative, right? Now, they look like the same exact numbers of Q1 because, again, they're dealing with the same special right triangle that we proved a bit earlier, right? The only difference is the x portion, right? This is going to the left, so your x portion, or your cos, should be negative now, okay? Now, let's look at Q3, right? Q3 has the values of 210, 225, 240, and 270. Okay, they have the exact same ratios. But notice something here. They're all negative, which makes sense because the only thing that should be positive here, is tan, right? So cos and sine are all negative here. Again, they are the same exact ratios, but they're just negative. Let's go ahead to Q4 and remind yourself what should be positive in Q4. Well, cos should be positive in Q4, which we'll see in just a second. Okay, and as you can see, cos is the only thing positive here, and sine is negative, right? Sine is negative here, here, and here, okay? And cos is the only thing positive, okay? Now, this unit circle, right, which we have basically completed, you do have to memorize. But the good part is you are only memorizing Q1, right? If you can memorize Q1, you basically can get Q2, Q3, and Q4. Now, the reason this is important is because if I ask you, what is cos, if I ask you, give me a second here, if I ask you cos 210, right, you do not have to recreate your special right triangle, it's simply your answer is right here. Cos 210 is equivalent to negative square root of 3 over 2. Well, what if I ask you sine 315, right? Well, I don't have to recreate my special right triangle. I can, but the quick way to do this is simply just say, well, sine is right here. Sine 315 is equivalent to that. So I'd simply say negative square root of 2 over 2. Okay. Well, what if I ask you cos 180, right? Cos 180 is equivalent to what? Is equal to negative 1. So that's why your unit circle will quickly give your ratios based upon your angle fairly quickly. Okay. Now, if you're wondering where tan is, tan can be represented as opposite over adjacent, or in this case, sine over cosine. Okay. So what I mean by that, tan can be represented as sine theta over cosine, right? So if I'm asking you tan of 120, all you really have to do is find your sine and find your cosine and set those up, right? So sine theta is square root 3 over 2, and cosine is equivalent to negative 1 over 2, and you would have to just simplify there. Now I don't want to make this video too long, so I'll let you do that by yourselves. But essentially, this is how you want to use your unit circle. Okay? So you do have to memorize this. And again, it might seem like it's a lot to memorize, but if you simply just focus on Q1, you will essentially get what everything else is, because the same ratios will apply.